Today I'd like to talk to you about angular measurement. Now in the workshop you'll need some tools to measure different angles. You may start off doing woodwork and all that type of thing and have a combination square with a protractor on it. You can just adjust that, shift the angles out and scribe that and off you go. You may even make up some templates. If you do a lot of 45 work and you want to hold in a chuck, just make up a little 45 jig, 30-60 jig. You can just put that in the bottom of the vise, slide your job along, nip it up and it's done. And if you've got a special angles you want to do a lot of, you can make that out of sheet metal. Or before digital was around, there was gravity. So we used to have these type of gauges. It's used in the building industry when they're doing the roof. They also can calculate angles. But sometimes you want to do job 45, that sort of thing. That's also available. Then at school, you would have had your protractors. These ones I've machined up, erudite to a bit alley, machined up and drilled a hole in there so as I can attach it to crankshafts, that type of thing. Get angles before top and after, top dead center. There's a larger one that I made, just engraved, no measurements. So you can use all these. You may invest in a very accurate protractor. I've got a Russian one, smaller, and I've got this larger one. Very good, very accurate, and very expensive. If you do a bit of precision setup work, you may get yourself a set of angle blocks. Hopefully you've watched my series on the step blocks and tapered parallels. This is part of the sort of family you should get. They come in different sizes and you just stack them up to get the angle you want. Good for jig work, setting up work on your surface plate, that type of thing, checking angles. Then we now enter the digital age, where everyone's cheap, put a battery in it and it's fantastic. You may have purchased this type of protractor if you're digital protractor, angle gauge. If you've watched my series on the 3D printing, setting up the Kossel 3D printer, you'll see how I use that to set things up square. Now these are great. You may even go on down to Aldi and got the tilting ruler. They're also great for what they do. So depending on whether you're making something out of wood, sheet metal, up on top of your roof, precision work in the tool room, doing sheet metal work, or just a quick chamfer you want to put on a job, templates out of alley. If you're doing any motor work, crankshaft setting, timing and all that. If you're doing precision work, setup work, also available. Doing the angles, a bit more accurate, these are also cheap. But one thing you've got to remember, like digital vernier calipers, anything digital, digital clocks, digital thermometers and all that, they can put as many decimal points as they like behind the end figure, but look in the packet and read how accurate they are. I had a digital thermometer, it used to go to 0.1 of a degree, it was accurate plus or minus 5 degrees. So what's the use of having 0.1 of a degree show up on the dial when the instrument can be out 10 degrees? So it's the same with these. Don't think because it says it's 0.15, it is 1.5. It's a variation. So these are all great. But what happens when they have to move? Any of the others? Okay, this one can move. The other ones, they're for a set angle you want to measure or an angle you want to set, and that's it. That's why I've got my 5-axis tilting rotary table there and explained the job that I needed, an angle that moved to be accurate and what there is available. We've all seen this type, but as they go around, either don't flip over or you get errors in them. They're not that great. I'm making up a grey code encoder to show the index position of my automatic tool changer, the turret, the carousel on that. So I had to have a series of engraved marks, grooves, as these pictures will show, certain start angle, certain end angle. I can use the dial on the rotary table, and most rotary tables are 90 turns for one rotation. Dial is there for in 4 degrees. Now the problem I had was they're all different starting positions, ending positions. It's fine if you can go 1, 2, 3, 4. If you want 7, 13, 22, 28, 42, 79, etc., etc., 32.48, 29.75. And these only show you 0, up to 1, up to 2, up to 3, up to 4, then back to 0. So very easy to lose count, very easy to make a mistake, go too far or too less. When you're indexing teeth, that's fine. You can turn it, 150 turns, have a look. Oh, that's a little bit out, man. Oh, you went too far. When you're machining, you don't get a second chance. You put the cutter in, you're removing metal. You go too far, you stuffed it. So I wanted a solution that would make it easier for me. And just like this type of digital angle gauge, I got what they call a rotary digital angle gauge. And you've seen this type before, similar to these, but this is not it. This is the actual readout. On the other side of the rotary table here, I'll show you in these photos, is the actual encoder. So as the encoder rotates, this is the readout. This is just a network cable, and you can have them 10, 20, 50 feet long, and I can plug this in anywhere and I can actually check it from any position. It's magnetic, sits up anywhere. Also, job with this, I did try it, put it on there, so okay, set it to 0, you wind it, and when you go 180, it's upside down, and they're prone to move, that sort of thing. So this is just a readout. You can set it to 0. When you count from 1 to 2 to 3 to 4, that's okay. But when you're going backwards and you have to go 17, you go 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 2. Is that 17 or 18 or 16? Like I said, it can be confusing. So with this particular one, don't know if you can pick it up, on this Morse Taper 3 ER32 chuck. If you've been a good viewer and you've watched my video on dual chuck replacement, this is the one. Has a thread on the other end. I've made up a stud. I reamed out the whole 1/4 inch to hold the encoder. This series of photos will show what I done. Drilled and tapped little hole for a little 2mm grub screw. Holds in position. Use these packers to keep it in position because it's free to rotate. And just done this. So even though this was on 0, I could turn it and it might say, again, these are not in decimal degrees, these are in degrees, minutes and seconds. So you have to convert 60 into 100 to get your 0.1. This also is only digital. My drawing was in digital, so trying to convert it, write it all down, I'll get close and check. And I would say it probably doubled, if not tripled, the speed in which I machined the little grooves in. Because you're confident, and if you're confident, you can turn, coming up, slow down, and there it is. If you do it the manual way, 1, 2, 3, 24, 25, what was it? Oh, okay, 27. Oh, what was I up to? You can make mistakes. So look for one of these. You can attach it to anything you like, put an extension on it, and it is fantastic. This is called a Machine Dro digital angle gauge. I bought it in 2012 for 81 bucks. So maybe cheaper, maybe dearer now, but well worth it. And I can just put it up here. Again, looking to read, I can put this in a good position to see it. If you've enjoyed this video, tell your friends. If you haven't, tell me. Don't forget to subscribe because we've got to get up to 2,000. And as always, thanks for watching.